The light pollution filter in the Seestar S50 is designed to reduce the negative effects of artificial light, such as street lights. On astrophotography and stargazing pictures, that's important to reduce that excess light. Light pollution from urban and suburban areas emits unwanted wavelengths of light, primarily in the yellow and orange spectrum from sodium and mercury vapor lamps. This can wash out faint celestial objects, making it harder to capture details in deep sky astrophotography. And how the light pollution helps is first, it enhances the contrast. It blocks specific wavelengths of artificial light while allowing more of the natural light from stars, nebula, and galaxies to pass through. Next, it improves the clarity. It reduces the sky glow effect, making dim objects more visible. And then it boosts color accuracy and it preserves the natural colors of celestial objects by filtering out the artificial hues. And then last, it better it produces better deep sky photography. It's particularly useful for capturing nebula, galaxies, and other faint objects in light polluted areas. If you're using the Seestar S50 in an area with significant light pollution, enabling this filter can help you get a clearer, more detailed astrophotography shots without the need to travel to a dark sky location. However, in extremely dark skies, the filter probably isn't necessary. So this plan, I decided I wanted to test the light pollution filter and see if we could see any difference when we used it and when we didn't. The app does give us a little bit of guidance of when we should be using it, and so I'll point that out too. So as we build the plan. But this is the create a plan in the Seestar app, and I'm going to name it light pollution filter or no. And then I'll click confirm, and then I'll start building my light pollution plan. And my idea is to image each object twice. This isn't a real true scientific experiment because we don't have the same controls as we would use for a scientific experiment. We're going to record them just one right after the other instead of two sea stars running at the same time so that they're in the same time frame and same light that's possible and things like that. This is just an informal experiment that we're going to do tonight. So rather than spend a lot of time hunting around for objects, I figured I would just use the ones that it's recommending in the app as tonight's best options. And those are up at the top of the screen when you are in the Seestar app. And you notice it does already show us when the light pollution filter is recommended. So the first one we'll add is the Andromeda Nebula or galaxy. This one is one that we probably all of us have done at one time or another, but I thought it would be a good one because it's familiar. So I will input it in the app and then we'll mess around with the light pollution filter. This describes it, it tells us its visibility. I don't see any indicators here to turn on the light pollution filter, so it's suggesting to not turn it on this object. Here's Andromeda's trajectory in my night sky. So I don't want to go up over that apex of the trajectory. So I'm going to do it early in the night and then I'll maybe resume it after that apex. I forgot to take into consideration that I'm making this plan earlier in the day and it's past that apex. And so when I input it into the plan for later tonight, it's past its apex and on its way down. And so I've added it to the plan. I'm not going to do it for long periods of time because our goal tonight isn't long, fabulous exposures. It's to test the light pollution filter. And so when I add that to the plan, that light pollution filter does not turn red because the Seestar app is not recommending that we use the light pollution filter on this object. And so I've added it to the plan first off in the lineup. Now I'll just add the same object again, and I'll manually turn on that light pollution filter and add it to our plan down. You can see it there. They're just one right after the other, and that's why they're not a great scientific experiment, but it's close enough for our use tonight. Once we've executed tonight's plan with all of the objects, I will share the results at the end of the video after we've executed it. The next one I'll add to the plan is the Orion Nebula, or M42. That, of course, is one that we've probably all done many times, but you'll see that it does recommend the filter in this one. And so it kind of gives us a clue in the app whether or not we should be using that light pollution filter. And this one is recommending it. And so when we go to add it to the plan, it will automatically turn that one on for us. And we're going to manipulate it so that we can keep it a little organized for our plan. Here's Orion's trajectory in the sky tonight. And so we'll get that added into our plan where it will fit nicely. So here's the Orion Nebula. We're going to add it to our plan, and you'll see that the light pollution filter light turns red. That's because they're going to automatically turn it on for us. I'm going to manipulate these just to keep them in an order for us for viewing later on, but it does automatically turn it on if they recommend it. And you can turn it on or off, but that's what they recommend. Here I manually turned off the light pollution filter for M42, and I'm adding it to the plan. Then I'll add it again with the light pollution filter on. So my first image will be with the light pollution filter turned off. The second one will be with it turned on. The next one we'll try to add to the plan is M1, or the Crab Nebula, and this one does recommend the filter, the light pollution filter. And so again, this one, when we add it to the plan, will automatically turn on that filter. We'll manipulate it again just so that they're kept in a logical order for our plan. Here's the trajectory for M1, and we'll get it added to the plan. And like the last one, we'll turn off the light pollution filter for the first image and then turn it on for the second image of that same object. The next one we're going to do is M51, the Whirlpool Galaxy. And you see here the trajectory of that object. The app on this one does not recommend the light pollution filter. And so this will be a good way for us to test if that light pollution filter makes a difference or not. So here we'll add that M51 with that light pollution filter turned off. Then we'll add it a second time and manually turn it on. And so we can compare them. So here is our night plan. We're going to do each object twice. And the first time we image it, the light pollution filter will be turned off. And the second time we will turn it on. Haven't done a lot of exposure time on those first objects because our goal of tonight is just really to compare the light pollution filter and whether it makes a difference in these objects. The last two, they're a little bit more of a faint galaxy, and so I did want to add a little bit more time on those, and they were at a good position in the sky to do so. So I have added those in at the end with a little bit more exposure time on them. So we'll execute this plan, and then I'll post all the results and we can compare and see what we think about the light pollution filter and whether or not it made a difference in the imaging. And just as a heads up, in case you haven't watched some of my previous videos, the plan does indicate whether or not that light pollution filter is on down in the bottom of the plan. It will indicate framing as well, but this circle means that the light pollution filter is on. As I was preparing this video, I did some research in the app and trying to get some accurate information so I could share it. And you can figure out your light pollution Bortle scale by clicking this nearby button down at the bottom of the app. It's just on the main screen down at the bottom. Click that button that says nearby. Once you click on that nearby button, it brings up this map and it shows you the light pollution map. And I have to confess, I'm kind of surprised. When I first got my Seestar, I just Googled what my Bortle scale would be in my area. I typed in the zip code and my address in Google to get my Bortle scale number, and it gave me a different number than this map is. So perhaps all this time I've been imaging in a much more light polluted area than I thought I was. So this was kind of an interesting learning experience. You can click on the little graph at the bottom and it will open this screen and make it a little bit bigger so you can read. So I'm probably in Bortle 6 rather than all these months that I've had my Seestar. I've been reporting I'm in Bortle 5. Maybe it's kind of in between those two, but it is a little bit different than Google told me. So that was a surprise to me. There are little devices you can buy that will measure the light pollution in your area. I have never invested in one, so I don't have one. So I had to rely on Google and maybe the app too. So just to clarify. All right, it's several nights later, and we weren't able to execute the plan until several days later because of darn cloud cover. But the results are in, and this is our first object, M31, the Andromeda Galaxy. And this is the picture with no light pollution on. The filter was not turned on this one. So this was image number 1. And just to keep everything as consistent as possible, I didn't do any adjusting in the app. I didn't lighten or darken or add color or anything in the app. I didn't do the denoising. This is just straight off the Seestar as it's saved. And so this is image number 1. This first image was a little weird. It didn't center it. I'm not really sure why, but the second one is in the center, so I don't know why the first one wasn't, but we did get a picture of it though, so we'll still do our comparing. Here's version number 2. They both saved right around 36 or 37 minutes worth. It looks like the one on the right, it says it saved 40 minutes. I think it was 39 point something, but they're really pretty close in minutes of exposure. But you can certainly see a difference in the color, and so it is blocking light. That pollution filter is blocking some wavelengths of light. So it's pretty interesting. They are different. Which one do you like better? Would you recommend having the light pollution filter on or off? And just as a reminder, the app suggested to not turn it on, so they would have recommended the picture on the left. Our second object is M42, and this is the version with no light pollution filter on. Just as a reminder, the Seestar app recommended we did turn on the light pollution filter, but this one is our test with no light pollution filter. It saved about 40 minutes of exposures. It's real similar to the others from the previous objects, so that's kind of interesting too. Here is that same object with the light pollution filter on, as recommended in the Seestar app. This one also saved 40 minutes of exposure time. So that's kind of interesting that they both ran for the same amount of time and saved the exact same amount of exposures. You can really see a big difference in these two. The color enhancement on the right is so much better than the one on the left, in my opinion. And so if I were to vote, I would say the Seestar app was spot on when it said to use that light pollution filter. What do you think? What's your opinion? Our next object is M1, the Crab Nebula, and this is the version with no light pollution filter turned on. And just for reference, the app does suggest that we turn it on this one. So this is doing what the app tells us not to do. And this one had 38 minutes of exposure time on it, just for reference. And here's the version with the light pollution filter turned on, as the app suggested. This one has 40 minutes exposure, so just 2 more minutes of exposure time than the first image. And so you can see that there is quite a bit of difference. This one was a little bit tiny, so I wanted to blow it up a little bit bigger so you can see it a little better. So you can see the difference that light pollution filter made on this object. It does make quite a bit of difference. The one on the left actually kind of looks like I clicked the denoise, but I did not. So this is only the light pollution filter is the only difference. There was no editing, no enhancing, no denoising, nothing. Here is M51. This is our last test object. It's a Whirlpool Galaxy, and this one does not have the light pollution filter on it. And you remember from our plan that this one we spent a lot more time on at the end of that evening plan. And so both of these exposures for this object are a longer period of time. This one saved 80 minutes of exposures. And so that's quite a bit. For one, the Galaxy came out great. It's beautiful. It would be great to do some post processing. But you do see that there's some light pollution in this one down in the bottom right, and you can see the field rotation up in the top left. So it does show a lot of flaws in this one. Wow, what a difference the light pollution filter does on this one. Just turning that light on, you can see that all those flaws of the light pollution are no longer there. This one has 74 minutes, I think, if I can see that number right. So even a little bit less than the one on the left, but it definitely makes a difference in this picture. So this is the only one out of our test objects that the app got it wrong. I would definitely turn it on this one. And so you can see what the difference makes so that you can kind of figure out what your conditions are, what objects you're imaging, and then plan accordingly. The app isn't always right according to this test, this informal science experiment that we've done. I would definitely want to turn it on this one, wouldn't you? This is that same object. I wanted to enlarge it so that it would be a little bit more visible so you can see the fine detail and the difference that it makes. But the light pollution filter definitely made a big difference in this one. A lot more light came through on the right hand side. I keep changing my mind which one of these I like better. I really like them both. I can see some advantages to both. The one on the right would be easier to add color in post processing, and because it's not all blurred together, the one on the left is a little bit more gassy looking, and it doesn't have the um, pixelation on the background. So I keep changing my mind which one I like better. But what are your thoughts? Which one do you like better? Would you have gone with the app and left the light pollution filter off, or would you have bucked the system and turned it on and been a rebel? I don't know. I like them both. They both turned out beautiful. This was a fun science experiment, even though it was an informal one. What do you think? Should we do more of these kinds of experiments? Should we test a few different objects, maybe a little bit more controlled experiment? What are your thoughts? We appreciate everyone who supports the channel. Just giving a thumbs up and a comment, subscribing so you get our content helps us out. And we appreciate everybody who's following our journey. And we're wishing clear skies to everyone. Thanks for joining.